I'm recording. Big shout out to Mason. I don't know what to say for you. Anyways, but first thing we're going to start with is the skill that actually you guys kind of have seen this, especially during implicit differentiation. We're going to try it again. Differentiate each expression relative to time, t. Now, I look at this, and there's no t in here, but if I differentiate relative to x, or with respect to x, what symbol do I use? D by dx. So in this case, and you knew it, it's coming. This just means apply the operator, the differentiating operator, d by dt, to each expression, even if there isn't a p or a t in there. So I think you guys will know what to do. Okay, if I apply d by dt, the operator there, yeah, this looks like my implicit differentiation thing. And this is where you've seen this before, but I want to drive it home here. So what is this expression? Because the t doesn't match the p, so what do? We're assuming p represents, it's a variable, no? So what's the derivative here? Back. It's not too far back.
I don't remember, but 6p. Yeah.
6p doesn't match, so the derivative of p with respect to t. dp by dt.
Yeah, it's like doing the outside.
Yeah. It's all coming back to, ain't it?
Like I mean,
Well, that's the chain rule. And yes, this very well could be the chain rule, because maybe you have an expression p that you could actually operate with if later on we find out that p equals t cubed plus 5t or something like that. You can do the onion thing, do the inside chain rule too, yeah. Okay, now apply away d by dt. I'll let you guys rip through these and I'll check them over with you in a minute. I'm just writing them out. You guys don't be late work today. Take these out. Okay, if you're watching the video, pause right now until you've done all the answers. Okay, you've just unpaused the video because you did them all, or else you're in my classroom and you did them all. Maybe you didn't get right to E yet, but hopefully, does this one make sense? This one makes sense, straight ahead. Okay, just like before. There's no tricks to this one. It's two different variables, but they're not being multiplied, so no special rules really. 3x squared dx by dt, 2y dy by dt. Stop me if I make an error, I often do. They aren't on purpose. Okay, this one here I wanted to do with you just to make sure we have a product of two variables, right? A squared b cubed. So we're going to apply the product rule. Derivative of the first thing, leave the second thing alone. So 2a, I'm going to write the dA by dt behind it though. B cubed, dA by dt, it's just my habit. You could put it in the middle, as long as you show that it's multiplying. Then add it, because it's a positive sign there. Yep, product rule, good. So leave the first thing alone, a squared, 3b squared then. I'm going to put the 3 in front, just because it looks better, but and then dB by dt. So I know people still sometimes made the odd error and stuff like this. If you want to put the 3 in the middle, by the way, if you were doing it, like if you went in order, a squared, use a bracket, 3b squared, dB by dt. Just so it's not ambiguous or whatever, if you have just a 3 in between an a and a b, a3b, you know, like it doesn't always it's not standard to write it that way. So if you wanted to do that, that's the same thing. Now, try this one here real quick. Should be a quick one. I just made that one up. Yeah, it's a match, right? It is time, so with respect to time, there's no leftover. 7/2 times 2 is 7. T. 7t is the derivative. That's it. 7t. Like this part, 7/2, and then t squared. I make a little hook at the bottom, a backwards J kind of with my t's, so you don't get confused with plus signs. I'm in the habit of making 7s with dashes, so people don't get confused with the number 1, because I know a lot of students, nobody here, I know some EAL students don't make a bottom to their 1s, you know, sometimes they make their 1s that look like 7s. You know anyone who does that? Just thinking when you were you in EAL classes like initially? And some students do. Where is that common, actually?
We actually, like you know how you have the bigger letter A, B, C, and then the smaller letter, so when you use it in a sentence.
Okay. And this would be your number 1. Is that what you grew up doing, number 1 like that? Or no? Yeah? Okay. That's why I make my 7s like that. And actually, I've done that for a long time because I remember teaching a student who was an exchange student about 12, 13 years ago. Okay. This is a skill we'll continue to use. Moving on. We haven't actually started working on a related rate problem yet. We'll do this a little bit. This is a smaller, simpler problem I've made up just so that we can understand what we're talking about a bit. So this one, well, let's just read and see here. Okay, I'm going to read through. An object is dropped as you're standing on a high bridge. Immediately after you drop it, you start traveling at a constant speed, and your position is given by A. The object is falling under the influence of gravity, so it approximately is accelerating at 10 meters per second squared. You guys use 9.8 meters per second squared in physics, correct? 9.806 sometimes? Okay. So I'm using 10 just for easy math. So here's the scenario. Here's the bridge. You're here at time 0. You haven't dropped anything, right? You drop it over the side of the bridge. It must be really high. Then you start cruising, zipping through. Okay. On your motorbike or something. So you were here. After 1 second, you started right here at this corner, right? You've zipped over this much. The rock that you dropped has gone 5 meters that way. You've gone 3 meters, the rock's gone 5 meters. After 2 seconds, you've gone 6 meters, the rock has gone down 20 meters. Now, we've got some things to put in here too. Now, first of all, I used whole numbers there, 5 meters, 20 meters, but if you're considering an XY axis, I was just labeling the side of the triangles, right? Would it make sense to do something a little bit different with those measurements? Because I'm literally thinking of a negative speed, right? Going, or like the object is traveling down. If I consider this 0 on an XY axis, now, what would your Y measurement really be then? Negative 20, negative 5, etc. Now, why don't we just do that, put in the negative signs there, just because it'll make, it works without, but sometimes people want negative signs, etc. in there. Now, I'll explain. What do you guys know about the direction that gravity pulls? Is it down or up? It's down, right? So, when I say it's accelerating at 10 meters per second, it's accelerating at, if we want to include direction, negative 10 meters per second squared. Mistakenly forgot to say second squared there. That means every second, the speed is increased by 10 meters per second. 10 meters per second per second. That's the square part of it, okay? Now, because this isn't a physics class, I'll tell you that the vertical position function in this case is 1/2 AT squared. You recognize that if you've taken physics, right? The initial speed was 0, so there's v naught t plus 1/2 AT squared is usually what you use, right? All these zeros. So I've just simplified it. So this is just a given thing for you. So what are we getting here? Well, let's read here. What's the value or expression for the rate of change in the x-axis? The rate of change. What's another word for rate of change? I'm using the math words. The common word in this scenario, where we're talking about accelerations and distances, the velocity, if you include direction, yeah? So what's the speed or the velocity? In physics, you're careful. Speed doesn't include direction. Velocity does, positive or negative. We will more or less do the velocity because we're taking positives and negatives. So, do we get a value or do we get an expression? What does it seem like? If you start at 0, then you've traveled 3 meters after 1 second, 6 meters after 2 seconds. Can you tell me about that rate of change in the x-axis? What is it? 3 meters every second. It seems to be increasing at a steady rate. So we don't need an expression here. Now, what is the value expression for the rate of change? So what would we call that in the x-axis? Instead of, in math, it's the change in the x value over the change in time, right? But what's the calculus way of writing that down? Derivative, so I know this is new to you or whatever, kind of new to you. Would it make sense then to say dx by dt? Wouldn't that mean that really can be translated as the change in the x-axis as time goes on, as you change time? And it's equal to 3, I'll put in the units here too, meters per second, okay? We just reasoned that out by saying, well, 3 divided by 1 second, okay, yeah. And then the second 6 meters divided by 2 seconds, oh yeah, it's still 3, so it's steady. We will assume he's traveling at a steady rate of change. And it is constant, it does state that, okay. What's the value or expression be for the rate of change in the y-axis? Well, we have a vertical position function. When we see rate of change in the y-axis, what do we want to find? Calculus-wise. It's the speed function, though, but what speed is, or velocity is, the derivative of position, right? Position is given by this expression, so what do we need to do to that expression to derivative? dy by dt is the speed in the y-axis, really. The change in y over time, the change in time. So let's think of it that way. dy by dt, it's not a difficult derivative. 1/2 AT squared. Now the a is not a variable, we're told it's constant, it's gravity, negative 10. Let's just keep it as a and we'll sub in the 10 after. So AT, yeah. The square from t squared comes down, cancels with the half. So AT, which in this particular case, because it's a constant acceleration due to gravity, we're going to say is negative 10 t. I apologize to the other side of the room, these guys always talk. Wave your hand if you need me to clarify something. Now, this one, and you could probably tell, and I think you know from your experience too, when you drop objects and they're traveling down, the speed is not constant, right? That's why you don't get just a number. You get this linear function. It's, right? Okay. Now what? What's an expression for the distance between A and B? Let's call the hypotenuse C. Right? So, isn't that a kind of leading question? Yeah.
The B, that equation, a negative 10t,
Okay.
is that giving you position or velocity?
Is it position or velocity?
Like,
Well,
it's
this is
not-
definitely the position.
Yeah, it can't be. Oh, yes, that's the velocity.
This is the change in position over. Yeah, okay. So it's velocity. It's a velocity function. Yeah. And I'll say velocity is a better word than speed because we're including direction. We've thought about direction.
You can't.
We're assuming negative is down. So when I say between A and B, you see how my B is down here? My A is up here, okay? Or this triangle, A and B. Now, can I just say 3 squared plus 5 squared equals this distance? We'll call it C. That's only valid though at that first second. Would you get the same answer here for C? No. So we can't just say 20 squared plus 6 squared equals C squared, right? It's changing all the time. We're going to call this C though, just because I asked you to. C squared, well, let's just use the variables then. The horizontal is x, y, x squared plus y squared. We can't just come up with one number. It's an expression. Now, it's an assumption that everybody knows Pythagorean theorem, right? Now, what's an expression for the rate of change between points A and B? Now, we've called that distance C, right? Now, what are we talking about even? I said we call this distance C, but we can find out how fast this is falling at any given moment. We can find out it's always actually traveling at the same speed that way. But what we're talking about, and I can't do 2 fingers at once on the video here, is how fast these guys are separating. You know, it'll be a little larger in 1.5 seconds here. That rate that they're separating at, that's what we're actually finding here. Do you guys follow that? So if you look back and say, there it goes as you're walking away from the spot on the bridge. Now, what do we want to find then? dc by dt. C is that distance that we're separated from. So what we want is to find, because between points A and B, I told you to call it C. So the rate of change between points A and B, rate of change. Why did I put function here? Oh, I know what it is. I'm going to first say find, and this is going to disappear now. Find dc by dt. Okay. That's really what we're doing here. Do you understand why? Because C represents that distance between A and B. This will be the rate of change, the speed. And I'm going to call this one speed because there's really no direction. It's at an angle and it changes every second, right? Okay. So dc by dt. Well, here's my C expression, C squared. If you want to, you could isolate for C and say C is equal to the square root of x squared plus y squared, but then you got a square root in there, right? Do we know how to do the derivative? We don't have C isolated? Oh yeah, we do. What do? Apply the d by dt operator, right? To this expression. So what I'm saying is take d by dt. This side, I wouldn't normally write this out, but we're instructed here, d by dt of this side. Do it to the left, do it to the right, which we've always known, right? So this is what we're doing here. Okay? You guys know how to do this. Give you guys a second here. And I'll do it too. And do simplify it a little bit if there's something in common. Everybody agree with this statement? D by dt, every time the t does not match the c, the x, the y. So we have those. What could we divide out of every term? Factor. 2, yeah. So I'm going to just simplify that a little bit. It's not wrong if you left them all in there, but I mean, when you try to calculate. Okay. Now, we want an expression for this between points A and B. So to isolate for dc by dt, we just divide by c, correct? So that's looking cool. I'll do it over here a little bit. dc by dt equals that expression. dx by dt plus dy by dt all over the letter c. It's not just a letter though, it's a variable and it represents something.
It'd be x, dx by dt, and y, dy by dt.
Thank you. I'm missing that entirely. One of my famous mistakes. What do I do without it, Randy? I know. I actually heard him say it. But he would just sit and laugh and giggle to himself. And he'd have the only correct word, selfish guy. Okay. We do have an equation here, and it's possible that we could work it out right now. If you wanted to, you could sub in though, if you wanted to. You could sub in the root of x squared plus y into there, right? dy by dt, you could sub in negative 10t into here, right? We have a value for dx by dt. Wasn't it 3, I think? Yeah? Yeah. So we could sub in further. But we have an expression, and I did not say it has to be all in terms of x and y, right? So this is a valid expression. If you were told in terms of x and y, simplify, or x and y and t, I guess, you could sub in stuff. Or, I mean, I guess you could ask not just that as a function of t, you could say, too. However, yeah, let's go for that. Do we want to? Yeah, let's do that. What is x in terms of t? If we know, let's just think of this here. Let's get this as a function of t. What is x? If we know the speed, just from common sense kind of stuff here, if we know the speed is 3, what's an expression for x? X is the distance, right, that you're walking sideways? Distance is equal to vt. You guys, you've used that before when it's constant acceleration? Or I mean no acceleration, 0 acceleration, constant speed. So, okay, I'm revisiting this. X is equal to 3t. That makes sense, doesn't it? Speed times time. We have an expression for y here. Okay, that's good. We can easily say, well, c is x squared plus y squared, okay, under a square root sign. But then we'd have to sub in a few things. We'll do it as 2 steps. Yeah. This ain't fun. We'll leave out units when we put stuff in here, just because it gets messy enough. So as I said, x is the same as 3t. That'll give position at any time. dx by dt is the number 3, so we'll replace that. Y is the expression, isn't it? Yeah. I'll just look here on my paper. Yeah, 1/2 at squared, 1. But if we sub in the a, it's negative 10. So maybe I'll just backtrack here. In our particular case, 1/2 times negative 10 t squared, so negative 5 t t squared. That's our y expression in this particular case, right? If this was done on Mars, you'd have a different value for gravity. So we're going to use negative 5t squared. dy by dt, we have an expression up above. It's negative 10t. Over, and I'll do this as two steps here. We know that c from the Pythagorean theorem is the square root of x squared plus y squared. And then we could sub in for x and y in the denominator. We could tidy up things on the top too. I'll wait for a second here. Many blessings. So 9t, two negatives, so still positive. 50 t cubed over the square root of, well, the x expression squared, which would be 9t squared. Yep. Plus the y expression squared, which is negative 5, so 25t to the 4. Up, so 4 in a row 2. Now that's something to write home about. So, this allows you to answer E with just one plug-in. What's the rate that A and B are separating at after 2 seconds? You just put 2 in for all the T's. Now, and then I'll show you the second strategy. So, dc by dt, and t equals 2, it's a function of t now. So you get 18, 50 times 2 times 2 times 2, so 50 times 8. 9 times 4, so 36. 16 times 25. My goodness, 40? Or 400?
Yes, 400.
Okay, is it? I don't have it worked out, I was looking here. Crap. 400. We got calculators to do this stuff. Why am I doing arithmetic in my head like a 5th grader? Am I smarter than the 5th grader? No, I'm still doing arithmetic in my head. If I was smarter, I wouldn't take calculus. That's the smart thing to do. Anyways, you come up with an expression, you have this. You come it out, jab it into your calculator. Comes out to one sweet number. We'll put units on it in this case. Just enter it all at once if you want, but use 436. There you go. Square root of 436 divided by 418 divided by this. No, but just toss it into your calculator. I know you can't do this one easily in your head because you'd have to approximate a square root. There. I'll get it down to Is it 20.0 like no rounding? Okay. Okay, because in an AP question, let's get in this habit. It's not a physics question. 3 decimal places necessary so we can carry 4. So 20.0, 1, 8, and 6. Well, if you wanted 20.019 is fine. We're going to get in the habit of keeping 3 spots. What's the unit behind this one? Meters per second. And you go up to the top. Basically what you do is, when you want units for a derivative, you take a look, what's dc? It's the change in c. What's c measured in? It's a distance, so meters. dt, what's the distance measured in this case? Seconds. Meters per second. So always look at your derivative symbol, if you have it like that, it'll tell you that. Meters per second. So A and B are separated at an average rate of 20-something meters per second after 2 seconds. Okay. Now, remember how I said really and truly you could have stopped right here and kept that? You could have, and all that would happen, and some people like doing this, if I didn't say as a function of t, and I didn't actually, you could have just figured out what x was at 2 seconds. Actually, it's figured out already. It's 6, right? It's up on the diagram. dx by dt, that was 3. You could have figured out what y was at 2 seconds, because you have an expression up above. dy by dt at 2 seconds. Figured out what c was from the c squared equals x squared plus y squared. And just put those numbers in after, calculated, you would have gotten the exact same answer, right? You could have done it as chunks. And when you're in a hurry, actually often that's the fastest way, is to stop like here, unless it was explicitly asked for as a function of t. Stop there, and then plug in all your numbers that you figure out separately, okay? There's no problems there. But I just wanted to show you, because sometimes you are asked for a function.